Good morning, everyone. Welcome to the fifth video on one concept, multiple tools, multiple learnings. And the topic today that I have chosen here is about vectors and scale. Though the topic is very simple, and many of us we always think, "Arey, what is there? One can easily do it." But this concept is very important, extremely important for the students to learn. So I start teaching this from the first year. But unfortunately, how many hours I teach, how many ever years I teach, for the past 22 years I have been teaching this, I observe at the end of the year, they still commit a mistake in addition of two vectors and maybe in resolving two vectors. So vectors is one such integral component in the learning of physics that until and unless they don't understand this topic clearly, they will not be able to solve any problems properly. Okay, definitely they might commit a mistake while they solve problems in the electric fields or maybe related to mechanics or whichever topic which has the vector introduction, which vector application, I see that they make a mistake. So, okay, now let us share. I think I have only two tools to share with me. So anyway, let me see this also. So I give this as an exercise. Okay, apart from they learning vectors in math, I tell them, okay, you need to work with this so that they'll get to know more about it. Let me share the screen. Vector addition. Right. So this is once again taken from PHET. PHET that way is a very good resource. I couldn't find anything apart from this. Of course, there's one more resource that I have here. This is a good one. Let us use one with this now. So what we can do now is that we can draw two vectors and then add them, and we can also infer many things out of it here. Now the first one is, let me take one vector. I have a vector A. I'll drag this, put it over here. Let me put it at this point. At some point where I'm able to measure it. I measure this. Okay. So the value of this vector A is equal to 10 units and the angle theta is equal to 53.1 degree. What does it tell you? It's the angle made by the x-axis. And then the value, the component of x along the component of the vector A along the x-axis is 6 units and this is 8 units. Okay, known to us. And then what I'll do is, so we have resolved the vectors. That's what we need to know. Now, how do you understand resolution of vector? Let me click on this here. So this shows you something here. Maybe so this shows you, okay, what is your x component and y component. Let me show you this one. The same x and y component are shown over here, but not in the form of a triangle, but in the form of x and y axis. Okay, if I click here, okay, then once again the same thing is shown over here. This also tells you the mapping of this along the x and y. Okay, so this point is 5 over here, this point could be around 13 over here, I think. So then it tells you what is the difference between these two. So this is how it has been helpful. In fact, you can change the coordinates, you can change the origin over here like this. You can do whatever you want using this. You're free to use this as a graphical tool. Okay, now what we'll do is, let me not all use all these things. Let me just come out of this and be using this. Okay, this will be fine for me. Now what I'll do is I'll take up one more. Okay, I'll just take values over here. I'll click on this values. This tells me about x and y components. This is the magnitude of the vector. I'll take up one more vector b over here and let me realign this. I'll remove this also. See, if I click on this one, I'll remove this. I'll just get only these values over here. Let me realign this so that I get a vector like this. Now the question is, I want to add these two vectors. This vector is of length 10 and this vector is of length 12.2. But this vector, if I click on this vector, properties of this vector are known to me. See, when it is highlighted, it tells me what are the properties of the vector. It tells me that the angle made by this vector along the x-axis with respect to x-axis. If I draw this x-axis over here, it is minus 35 degrees. Okay, see, whenever I take the angle in the clockwise direction, it always take it negative. But if I take it in the anti-clockwise direction, it's always positive. So for example, if you look into this here, see, you see here, it's plus 53.1, which means what? With respect to this x-axis, okay, it is calculating this value. It's calculating this angle. Okay, while if I calculate, let me show you here. See, this is the arrow you can see here. This arrow tells you you're calculating with respect to x-axis in an anti-clockwise direction. It is plus 53.1. But if I consider the anti-clockwise direction, that is, if an arrow is being directed downwards and I put the x-axis upwards over here, then what happens is you take minus 35 here. You can ask me, why do you want to put the minus 35 here? Why can't I put my straight line here? Why can't I put my x-axis here? Okay, so if you want to measure something, measure it from the tip of the vector, not from the head of the vector. Okay, there's something called as a vector has two parts. One is your tip and head. The second one is your length over here. The head denotes the final point, or what you call it as a direction, and the tip denotes the initial point, and then the length tells you the distance between the length and the tip and the head. Okay, we have got this now. Now what I want to do is I want to add these two vectors. Now how do I add these two vectors? Now when I say sum up this one here, it will directly give me the answer. Okay, this is what most of the students will do. They'll just click here and say, hey, this is the length of this vector. But how do I understand this? Okay, understanding this one is very important. So what we do is, let me pull this one here. The general rule is that the tip of one vector and the head of the other vector should be joined together. This is the head of one vector. This is the tip of the other vector. So I am going to join these two. When I join these two, so I join this, the third vector should be the resultant vector. I'll take up this third vector and align it in such a way that the tip of the first vector and the head of this vector are linked together. What happened? I got a complete triangle, right? So this 10 units and this 12.2 units gave me a resultant S, which is equal to 16 units. The resultant we call it as sum of the vectors. We got this value over here, right? So this we are able to verify our hypothesis that the tip of the one vector and the head of the vector, if they join together and they form an open triangle, open polygon, then the final side would join that so that you get a closed polygon. This is what it helps you. Now, if you ask me, can I verify this for the third trial? You can still do it for the third side also. Let me do one thing. Let me clear this whole thing. Let me take up three more values. Three values over here. Let me take one value here like this. Let me take another value like this. Like this. Let me take third value like this. Like this. Okay. And I have three values. I want to find out the sum of these three vectors. How do I do? Okay, I'll just click on sum. Without doing anything, I got this sum. I'll keep this sum somewhere over here. It is like this over here. I'll keep the sum here. Okay, and ultimately I want to show. Now, how do I show it? So what I do is, I have the same rule. The head of one vector will be joined with the tip of the first second vector. I'll take these two value. I'm going to join here. So I join this. Then the tip of the head of the second vector is joined with the tip of the third vector. So I'll take up this vector and align it with this over here. Align it with this over here. Then in order to close the polygon, I will now put a line over here. I'll take up this line and then I will close it. So it perfectly fits over here. Is it not fitting? It's exactly fitting, right? So we have arrived at the sum of A plus B plus C is equal to so much. You can still ask me, why is it like this over here? Why not I take a different value? So you can try it with those also. Okay, let us say, for example, I take up this value first. Instead of taking B over here, I will take up A first and I will add C next. Instead of taking A plus B plus C sequentially, I first take A, then I will add C to it, then I will add B to it. Do I get the same answer? That's what I need to show. See, these are something which we can show it to our students also. So I'll take A first. I'll keep the A somewhere over here. Then I'll take C next. I'm not going to take B. I'm going to take C next. I've taken C here. Then I'm going to take B also. Now, how do I take B? I have to take the B here. I have to join here. I have to join here. Okay, I'll do one thing. I'll pull this one here. I'll pull this one here because I need some space to do it. So that you can see it on the screen clearly. I can put this one here. Take this one here. And I'll put it over here. Now what I'll do is I'll take this one once again. And I'll do this. Now it fits exactly. You may always say that, okay, the shape that I got earlier was different. The shape I'm getting now is different. Of course, the shapes are different. But what I'm interested is only in this value over here. I'm not interested into the shape of each one of them. Okay. As an exercise, I can always tell you, find out whether the area of the first polygon matches with the area of the second polygon or not. If not, answer why. Okay. This is from a mathematics perspective. You can think about this and answer this. Okay. So this is how you can teach a student how to add two vectors, how to subtract two vectors. You cannot multiply two vectors. If it is multiplying two vectors, then there are several things that comes into. There are three types of multiplication, right? You have a dot product, you have a scalar product, you have a vector product, which I will not be able to show using this software. Okay, let me move on to the next one. Scalars and vectors. Once again. Now, what does this tell you? Now, once again, it tells you the same thing. Now, what I can do is I can now I can find out the components. Okay, I don't see any difference over here. Okay, let me take up, okay, I do one thing. I take up one vector here. I take n is equal to 2 over here, 2 vectors. It says about 2 points, 3 points, and so on. I take 2 vectors. I take one vector here. With respect to the origin, I will take another vector here. If I try to join it over here, what do I get? Do you think I'll be able to add anything? I won't be able to add anything, right? So this, you can actually play with this interface. Nothing else can be done with this. Now, how does it do it? Okay, what is that it does actually? If I have two vectors and I want to add two vectors, okay, how do you add it? Maybe you can say, first I will use this one, then I can go for it. Maybe I should have taught you this one here. Okay, let me just redo it once again. Okay, I have two vectors over here. Let me pull this, make it more visible. Let me make it more over here. And this vector is like this over here, like this over here. I want to add these two vectors. Okay, so what I can do is I can introduce this particular website for the student first. Okay, and then I say, if I want to add, how do I add? I'll click on this play button over here. So what does it do? It takes up these vectors, drags it to the tip with the head, and then it takes up these two tips, takes up these two heads, and draws a final vector. This will give you the resultant vector, right? That's what it tells you. Okay, and thus you will be able to draw, or you will be able to find out how to add two vectors. Okay, and if you want to find a resolution also, then you can go to this one and you will be able to find out the resolution of the vector also. Okay, so these two are very important. Now, where does it find application? If you look at this charges and fields, it finds applications in electrostatics. So for example, I have taken 3 charges over here. So this is having an electric field like this. It's having an electric field radially every direction. It might be having one direction like this. It might be having a direction like this. And this might be having direction like this. Okay, so when we come back to the electric field, many of you would have used this particular module. You know about this. Okay, I'm not going to redo this once again. When we come to electric field, we'll do this one. So now what happens is, we want to find the resultant. Where is the resultant seen over here? What is the application of it? The resultant is seen through the sensor. Where was the sensor available? Sensor was available here. This is a sensor over here. So I would have taken the sensor from here, right? So what I do is, initially the fields are being drawn. If I want to find what is the electric field at a given point, okay. So let us say, for example, I take the sensor, keep it midway, exactly at this point. Then you see it is showing like this. How do you prove that the electric field is over here? And what does it tell you? Okay, so you need to take up a problem from electricity. Probably you can teach this one in your first year and as well as in your second year also. When you're doing it in your first year, okay, you will not be using this one because students may not be aware of how to find out what is electric field, what do you understand by electric field. When they come to second year, IB2, definitely they'll be knowing about electric fields. Or while you are teaching this one, you can ask what is the electric field set over here, because in some of the MCQs that we have this particular question. 2 charges are being given over here. What is the electric field at one point, right? So you can use this one, and you can use the concept of vectors, and then you can take them back and forth over here, and then teach the vectors over here and say, this is how it works over here. Okay, so this is how the vectors can be taught. Okay, or I think of teaching vectors like this. Okay, so it's more easier. Most of the time I use Blackboard to teach it because it's more comfortable for me. But for the students, I actually put across this. It depends upon the type of student. Okay, if someone is more inclined to learn from the simulation point of view, then you can go with this. If you think, okay, you can do everything ahead only with chalk and talk, it's well and fine. Okay, but as we know, there are different types of learners, and especially in IB, we get a wide spectrum of learners coming from different regions of the world. So there might be students who are visually sound enough. There might be students who would be interested to write and learn and so on. So it depends on. Okay, so with this, I think I may stop here. So we have done 2 exercises on vectors. Okay, we'll see more. Maybe in the next video we'll look into more about what do you call the just a moment. Yeah. Okay. So what do you call this? The Subat equations. We have not done that so far. We'll do this one. And then there are other topics also, one by one, as much as possible in this vacation. I would like to cover most of them, some 100, 150 tools if you have in hand when the school starts, then it will really be useful. Thank you. Do like, share, and subscribe to my channel to get more updates on this. So currently, I'm not doing any MCQs or structure problems. I'm revamping my website also. We will see how it goes, and maybe I would like to invite more feedback from you to get to know what else you expect from this. Okay. Thank you. Thank you very much.